Okay, in this investigation, you just did some problems prior to this where you had shadows and you noticed that the shadow of the, say, the person or the pole were matched up to the height of the person or the pole, and you cross multiply and solved it. But the problem is it's not always sunny. We're not in ancient Egypt where it's sunny like 90% of the time. And so what if there's another little ingenious way that can help you do that, and you just need a mirror and a short measuring tool of some kind, and then you can measure skyscrapers if you like, as long as you have the space to do it. So you can go into Geometry Sketchpad, but I got a copy of it right here pulled up, and so here it is right here. And what you'll see is that light, let's just say the sun is over here somewhere, and the light is coming down here, just touching the flagpole. And you don't have to have sunlight, it could be a ray of light, okay, because you don't need a shadow here, just a ray of light. So if you see anything, you have light, okay? And so the light bounces off of this and comes down, hits the mirror, and bounces up. And there's a property in physics to do with light. The light travels in a straight line, again in Newtonian physics, not in Einsteinian world. And as long as you stay in the same medium, in other words, the air is the same medium, we're not transferring mediums, it will travel straight, and the angle coming in is called the angle of incidence, and the angle going out off the reflection, this angle here, is called the angle of reflection. And the angle in, or the incidence angle, and the angle out, or the reflection angle, are identical. Okay? And so this angle and this angle are identical, and you'll assume the flagpole is straight up 90 degrees perpendicular to the ground, and you're going to stand straight up 90 degrees to the ground. So we have a set of angles and another set of angles being congruent. So these triangles are similar as long as I move the mirror in such a spot that I can see it. So right now this angle here is the same as this angle here. Okay, so I'm going to stop the wind here for now. So there's our flagpole, and you can measure, these are easy distances to remember, from your feet to, say, your eyeballs. Okay, you can say the top of your head to approximate it, but is where you're looking at, and that angle is going to be excuse me, is going to be exactly the same as this angle, and you move the mirror until you can see the top of the flagpole. And then you're going to measure this distance, and your height goes with matches the height of the flagpole, and the distance from the mirror goes in the other side of the fraction with the distance in the mirror here. And so what you get, if we measure it, okay, if we measure this, your height divided by your distance in the mirror is the flagpole's height divided by the flagpole's distance in the mirror. And if I do that on here, if we do that, so you make this divided by this equals height divided by this and cross multiply, you will get 7.94 centimeters. Okay? So 2.57 divided by 2.62 is equal to x over 7.88. Cross multiply, and you'll get x is 7.94 centimeters tall. And that's all there is to it. You're still doing it, but you're just got, the triangle gets rotated. The small triangle is rotated. Okay, thank you.